The parts of a nuclear, we're going to start off with the history of nuclear reactions, okay? And you have to understand what a radioisotope is. An isotope of an atom with an unstable nuclei. And we're going to study that when we talk about different things changing into other things. We're going to deal with radioisotopes. And just like teenage girls can be unstable, okay, radioisotopes can be unstable too. I'm just kidding. Okay? And so the thing is, they're ready to change into something else. Okay, I should have said middle school boys. Okay. Anyways, so Roentgen is the first scientist, and I'm going to keep this as simple as I can. Basically, he looked and saw that when he shined rays on things, they gave back particles, and he discovered the X-ray through that. When you break your arm and you go and get an X-ray, they have that machine. They come over and they shoot the rays into your arm, and it projects, and it basically projects the particles back, and it makes your bones glow. And so that's why they can look at the film on that and see, if you've broken your arm or not. Well, he is the guy that discovered the X-rays. Henry Becquerel, he's a French dude, Henri, and he discovered minerals that emitted light. So when he was going into caves and he'd take a piece of rock and he'd say, wow, it was in the light, now it's in the dark, but yet it's still glowing. Well, that was called phosphorescence. And the further he studied that, okay, is he saw that those minerals were giving off, they were emitting particles. Well, that particle emission, okay, is radioactivity. And Marie Curie, who's one of the most famous female scientists, she was the one that looked over what Roentgen did, looked at what Becquerel did, and really studied things that were emitting particles. And so she is famous for naming radioactivity, which means materials giving off rays. And then Ernest Rutherford came along, and he's like the Mac Daddy of scientists. And he did his gold foil experiment, which we learned in atomic structure. He discovered the nucleus and later on the protons. And then he also identified alpha, beta, and gamma, or alpha, beta particles and gamma rays. And so that's what we're going to talk about now, is the difference between an alpha particle, a beta particle, and a gamma ray. And they all have a different structure and stuff like that. So the composition of an alpha particle, it's a particle. The composition of beta is it's a particle. And the composition of gamma is it's a ray. So it's like radiation, like light. So it really, it's like has density, no density. All right? The description is an alpha particle looks like a helium nucleus. It's a 4-2, okay, so that means we did this before when we did atomic structure. The 4 stands for the protons plus neutrons, that's the atomic mass. The 2 stands for the atomic number, which defines the atom. So you're going to see that an alpha particle has 2 protons and 2 neutrons, and it has 0 electrons, and so because of that, it has a +2 charge. A beta particle has 0 protons, it has 0 neutrons, but it has 1 electron. So really, a beta particle, that's what it is. It's a high-speed electron, and it has a -1 charge. And a gamma ray is actually just radiation. So it has no protons, no neutrons, no electrons. It's a 0-0, okay? As far as that goes, it's basically a photon, okay? Which is a high-speed particle, which is a ray, but it doesn't have any mass. Right? The symbol for each one, the alpha particle looks like an infinity sign or like a Christian fish kind of symbol. The beta particle looks like a bee with a little tail coming off it hanging down. And the gamma ray is a Y, so it looks like that. So you're going to notice these when we do reactions, you're going to see these particles. An alpha particle is always a helium, a beta particle is always an electron, and the gamma ray looks like 0-0. As far as the mass goes, and the gamma has 0 mass. Okay, the beta is the number's really, really small. It's like 9.84 times 10 to the -24. So we don't even. I'm just going to tell you that this is small, this is smaller, and this is 0. Okay, so when you're talking about the mass of things, alpha has the most mass, which makes sense because the 4-2. Beta has, the medium mass, and gamma has 0 mass. Now, as far as the energy goes, the alpha particle gives off the most energy. All right, it's 5, and what that is, that's mega electron volts. All right, mega, which is 1,000,000 electron volts, and volts is, the energy thing there. So that has 5. This has between 0.05 and 1, and gamma has 1. So if you're talking about energy, alpha gives off the most energy, gamma is second, and beta is third. And then penetrating power, last thing, is that an alpha particle can be blocked by paper, a beta particle can be blocked by metal foils, and a gamma ray can be blocked only partially, but can be blocked by lead and concrete. So even though you're in a lead bunker or a concrete bunker, it still doesn't take all of it away, but it gets most of it away. It keeps most of it away, and that's a gamma ray. So that's why, like, when you're talking about, you know, weapons and nuclear bombs and stuff, the shelters are made of a lot of lead and concrete, because you gotta stay away from that radiation. All right, so that describes the particles and the history of those particles.